Hi, and welcome again. So, it is now final. The Owasp Top 10 2021 is now official. Let's go and look at it on the projects and Owasp Top 10 link. And now we see that from the left on the prior video I did, it wasn't. It's no longer able to post comments for it as a draft. Now it's final. Now the previous version is the 2017 version that we looked at before that I created all my videos from. So right now, if we go into the projects and the Owasp Top 10, we will see that the Top 10 new list is now official and it is final. So let's have a look at it just to have a glance at how they created the new pages to relay information to you guys. So let's take the first one called Broken Access Control. It's like moves up from the 5th position. 94% of all applications were tested for some form of broken access control. The 34 common weaknesses in operation mapped to broken access control had more occurrences in applications than any other category. So this is a very serious one these days, it seems. So let's just have a look at it. How does it look? The graphics, how do they present it for us? So they created a new UI, which is exactly the same, it looks like that at least, compared to the one I did in the first video I did about the Owasp Top 10 2021, about the draft version. So the new version is first presenting us with factors, talking about CVEs mapped, max incident rate, and so on and so on. Now, these statistics are the factors, and if you wish to have a glance at how they came to these numbers, I'm pretty sure that you could just follow the CVEs and do the math reverse. It's probably not easy, so it's not something you should figure out lightly, I guess. Then we go to the overview, description, and the description itself kinda provide us with the overall understanding of what this is all about. The most important part is the one how to prevent. So how to prevent, we'll talk about how we can avoid having broken access control, which steps we can take, but overall really fast, not that deep, it's just bullet points. Okay, so they do talk about some example attack scenarios, showing some code. And let's see, in this case, it's a scenario on the application uses unverified data in a SQL call that is accessing account information. So it requests some. It looks like prepared statements. This one, PT prepared statement does look like that. And we request a variable from the URL called ACCT and just put it inside. Unverified data. So this basically means that this part here that I'm marking the screen is the unverified data that is used directly in the SQL sentence. And we all know that unverified data or unvalidated data directly put into an SQL sentence might not be the right way to do it. So it talks about another attack example. It gives us some references to Owasp proactive control, enforce access control. Now this sounds very interesting, so just look at it just for a moment. Open the new one, C7 enforce access control, and it talks about access control authorization is a process of granting. Okay, so it kind of talks about the different kind of access control methods you can use. So called the DAC, discretionary access control, the mandatory access control, the role-based access control, or the attribute-based access control. 4 different versions of access control that you can use. If we look at the to the right, we see something called table of contents, and the table of contents talks about the overall project, about Owasp, about the project document structure. However, it has C1 to C10. Now, I don't know what C stands for, but let's just call it rules for now. So the first one is called C1, define security requirements, and we're looking at C7, which is called enforce access control. So nice to have a small menu that we can click on. let's just have a look at access control design principles. Design access control thoroughly up front. Of course, we need to think about how we define our access control, because if we do it wrongly, just a little bit, then we have broken access control, which is exactly what this is all about. Force all requests to go through access control checks. This is a typical thing that I see many developers forget, that they have some part of the application that does not go through the actual access control check. So they think, oh, so I have some public pages like the about page or the contact page, but maybe it is just a really good idea to let every single request go through the actual access control check mechanism to just verify, oh, this is actually a public page, then it is a public page. It's a lot easier to add pages to an already working access control management system, as opposed to having like something that is not checked and something that is checked, and then you have to find out whether to add it or not add it, and it's just it's easy just to say everything go through this way, then it's final, and we can make some rules for it, and in the long run it'll just be better. Deny by default, principle of least privilege, don't hard code rules. Oh yeah. Many application frameworks default to access control that is role-based. It is common to find application code that is filled with checks of this nature, and this is some things that I see a lot. And what I kind of think is, of course, if it's just a small, tiny, bitty application for, let's say, a small restaurant selling pizzas, and you just want to log on and add a new pizza recipe. If that is the case, if that is the application and that's it, no information whatsoever other than pizza recipes that is going online public anyways, I wouldn't say it wouldn't matter, but this is not the case. We're not talking about a small restaurant dealing with pizzas, right? But it's just to say, of course, there is a margin for, too small for it to make sense, to make all this object orientation, management of code, putting everything into a big architecture. Of course there is a limit, and this is something that I do meet a lot of people asking questions about. When should you put your mind to not using frameworks? When should you just create something vanilla code and just say, yeah, this is too small to be even to be used for a let's say bigger framework like Laravel or whatever framework you're using, and is it bad just having very simple access control or authorization with a very simple password? If it's just a pizzeria, a restaurant selling pizzas, and the only thing they can do is to add a pizza, it's number 15 with shrimps and whatever pineapple, right? So is this really a thing me to think about? I would say, depending on where the web page is located, it could lead to some things in the end, but I would say think about what you do your risk assessment, and then from that pick the right solution. So that was a sidetrack. Let's just continue a bit. Lock all access control events. Yeah, insufficient logging was one of the vulnerabilities from Owasp 2017, and I think logging is something that many people do actually forget. They have a tendency to, I see many programmers have a tendency to write a lot of code. They do it well, use some frameworks, use that, get it to production, get it online, but in the long run, whenever something happens, something gets hacked, you need to find out how did the hackers do it, how did they get access to whatever account. If you don't have the actual logs, for it, you cannot see how people got access to certain part of the application, then basically you are screwed. So of course you need to log events. I like this new layout a lot, so I would say this is better for me as opposed to the old one, which was a bit more abstract, put up in a way with let's just have a look at it just for the comparison. So let's go back to top 10, the previous version 2017, and pick, let's say, broken access control at the 5th one. You know, this color, it was okay. I how to prevent, it's a vulnerable reference and stuff. It worked, but I think the new version for me brings out a better overview of what I can do about broken access control, how I can attack it and combat it to mitigate myself out of the threat to some sort of risk neutral risk. So let's go back again to the original new one. So let's pick broken access control one more time. If we look to the right, we'll see table of contents, and what we see is factors, overview, description, how to prevent, example. The last one called list of mapped CVEs. Now they talked about 34 different ones. If you wish to read about the individual small ways to misuse access control to gain what is called broken access control, you need to read through all of these different CVEs, which is commonly known as common weakness enumeration, and all of them will in some way give broken access control. Owasp, they do have some other very interesting parts that we need to look at, and the first one was called Owasp Proactive Control Enforce Access Control. And when we click that, we got to the C7 Enforce Access Control. The next one is called the Application Security Verification Standard version 4 Access Control, which is another very interesting page talking about the ASVS, the Application Security Verification Standard, which is Owasp takes to a security verification standard for your company to work for your web applications. Let's see, they talk about the new version. We can go to download page and just look at it. So let's just click at the download page, and let's take the one called version 4.02. It's an English version on the PDF file. So it's being downloaded, and I'm gonna open it. And basically ASVS is consisting of 14 different categories that is in web applications. So from that we can get a really thorough process of going through them all, whether we have, let's say, something about file sharing or access control, which we probably do in most occasions. This video is not about ASVS, so I'm just going to close it again and go back to the overview. It also gives a reference to the testing guide, authorization testing, which is something that I haven't looked at before, it seems. Maybe I have, just not from this link. So it's testing directory traversal file include, testing for bypassing, authorization schema, testing for privilege escalation, and testing for insecure direct object reference. So if you take the first one called testing directory traversal file include, click on the link. It will talk about many applications use and manage files as a part of the daily operations. Alright. Using input validation methods that has not been designed deployed, an aggressor could exploit the system in order to read or write files that are not intended to be accessed. Alright, so in this part here, it talks about how would you test this vulnerability using a black box method. We talk about input testing and different kind of ways for you to. I'm just gonna scroll down a bit so you can see. Also, they do suggest different kind of tools you can use. Of course, burp speed is one of them. Dirtbuster is another one which I also use. So it's really good that they do provide some references to some interesting sheets. The other two ones, I would say, access control, which is really important. Please visit the authorization cheat sheet instead. The access control cheat sheet has been deprecated. Alright, so let's just click the link. Let's just verify that the link on authorization is not exactly the same it is exactly the same. So please pay mind to that these two links are pointing to the same place. So in the authorization cheat sheet, they do talk about something about the NIST. I can see NIST standard, and if you got if you read it all, it talks about denying by default, validate permissions on every request, and so on. And this is the overall cheat sheet for the authorization part. And there's a lot of things to understand and to grasp before you can actually create this with code. So I would say, if you're a new programmer, how would you use Owasp and so on? This is probably another video that I should create at some point, so I can show you how to use Owasp as a newcomer, as a person that just got an education, not particularly in any security direction, but just, I heard that Owasp is a good thing to use when I do web applications. How could that help me? If we look to the left, we see stuff like abuse cases, access control, and authorization, authentication, and so on, which is kind of the big list of all different kind of cheat sheets, which I think you should look at. Alright, so the video is getting a bit long, so let's just go back to the overall top 10. The second one is cryptographic failures, which is previously known as sensitive data exposure. Now, I would say that sensitive data exposure is probably the cause of cryptographic failure, but not the problem. So the problem is not sensitive data exposure, it is the cause of the problem. So instead of having a top 10, one of them is called the cause's name, I would say it's probably better to give it the name of the problem, which is cryptographic failures. I kind of agree with the name. Injection is now in third. Insecure design is a new category which focus on risk related to design flaws. Really nice. Security misconfiguration moves up a bit, because I would say more and more applications are created from Docker containers and virtualization and so on, which is going to, in some ends, push ahead all the security misconfigurations, because not everyone is fit to create good configurations. Vulnerable and outdated components is previously titled as using components with known vulnerabilities, which is still here, just a new name. And identification and authentication failure was previously known as broken authentication. And software and data integrity failures is a new category, focusing on making assumptions related to software updates, which is a really nice and interesting part, because CI and CD pipelines is something that I see. Well, just the whole continuous integration is a popular term. I want to say something about the word popular. Now, when it comes to security, the word popular is bad. When I hear the word, oh, this is a popular technology, I think, oh, many use it. Okay, so how many of those do know how to work with new popular technology? Well, I would say not that many, right? So that basically means that a lot of insecure software will be shipped. A lot of insecure configurations will be made. A lot of new Docker containers will be made with using some weird pipeline, you know. What I'm saying is, someone have to be the old madman, the old grumpy man, and that's gonna be me today. So popular stuff usually isn't good when it comes to security, because it means that someone took something and made it popular in a way, and a lot of people are gonna use it, instead of using good known develop methods. You know, the whole area of web is just constantly moving like a tsunami towards every you know, it's just like a ring expanding all the time. Everyone is gonna be hit by it. It's like, okay, you gotta use that technology, have to use that framework, you have to use this and that, and sure, but at some point you have to stop and think, what about the security part? What about thinking about, so we've been using Laravel for 5 years now. It's been really good. We have no issues. We're gonna change framework. Is that a good idea? Who make that choice? By which background did they people have? Like, are they educated in security? Do they know something about it? Was there a meeting about it? Was it just something like, oh, that sounds good because someone used it and just got a new education? You know, sometimes you have to stop and think, why fix it if it ain't broke? I know this is an old man term, like some old woman term, we're gonna say it like that, but it is true. So security is not popular, it is not shiny, it is not the press, it is not millions of dollars, it is not TikTok or anything like that. It is the things that matters a lot, that no one really want to think about. So I'm just saying that, yes, I'm gonna be the old grumpy man today. Security logging and monitoring failures were previously known as insufficient logging and monitoring, which is really nice to still have it. And the one called server-side request forgery is added in the top 10 community survey. The data shows a relatively low incident rate with above average testing coverage. Okay, so this is the 10 new web application security risks that is marked as the top 10 ones. Doesn't mean there's not a top 15 or top 100. It's just the 10 most interesting web application security risks to look at. This is the new standard from Owasp we're gonna look at. This is the new top 10 list. And I'm gonna have to create a new set of videos for the 2021 web application security risks top 10 list again. It will of course take some time because it's a lot of material I have to create. I'm gonna have to create some new slideshows. I'm gonna have to create probably some codes or some setup and some way to show things depending on how well I do it. So for now, I'm just gonna say that I'm really happy that the Owasp team took it out of draft and make it official now. It is 2021. It is about to hit October soon. So we couldn't really wait that long before we shifted to 2022. Alright, so I hope you liked this video, and if you wish to subscribe, and I hope you will, please subscribe. And if you have any questions, you can ask questions below in the comment field and I will come back to you with a reply. Until next time, bye.